This rock is matter. This wood is matter. Chuck here. He's matter. Even distant galaxies are made of matter. In fact, pretty much everything you've ever seen has been made up of matter. But would you believe me if I said that all of that made up only about 15% of the observable universe's mass? The rest, the roughly 85%, is supposedly made up of some other funky stuff called dark matter. Now, most people probably know a little bit about dark matter. I mean, Neil deGrasse Tyson is on television a lot. But what makes this such an interesting topic is that one of the highest regarded theories, named WIMPs for weakly interacting massive particles, is having more and more doubt cast upon it. So today I'm going to explain why we know dark matter exists and one possible explanation for it. Dark matter is a type of matter that you can't see, you can't touch, you can't taste, none of that. In fact, it doesn't even interact with ordinary baryonic matter, such as you or me, in any way except gravity. Or if it does so just barely. So how do we know it exists? There was a scientist named Vera Rubin, and she knew the before-mentioned laws. In 1968, Rubin and a colleague were measuring the velocity of a few stars in the outer end of the Andromeda galaxy. She expected the velocity of these stars to be significantly less than the velocity of stars near the center of the galaxy. But she discovered that these outer stars were not only moving just as fast, but that many were moving much faster. This implied that the gravity of the disk remained constant throughout, but there was no observable reason why. These galaxies should have been pulled apart long ago if it were not for this mysterious extra gravity being caused by some unexplainable stuff, and thus the problem of dark matter was born. One possible theory that is getting a lot of attention recently involves something called axions. Axions are hypothetical elementary particles predicted to be among the lightest in the universe. Axions are particularly unusual in that they're predicted to modify the rules of electricity and magnetism ever so slightly. Because of this interaction with electromagnetism, it is assumed that axions, when around something with a really strong magnetic field, such as a magnetar, which is a neutron star with, you guessed it, a strong magnetic field, they would be converted to radio waves, which could be detected on Earth. Initial experiments to prove this have come up short, but further testing, more specific testing, is still being done. A Russian research team tried to prove that axions exist in another way. They used active galactic nuclei, which are galactic centers that emit massive amounts of EM radiation. They tried to see if this radiation would be polarized in empty regions of space, which would prove that a cluster of axions was present and hence prove its existence. The team didn't find any evidence, but many other people are still looking. Axions are just one possible explanation for this fascinating problem, and with recent technological innovation and recent effort, we might just be able to solve it.